I tested out 9 different hardware wallets so you don't have to. But I tested these hardware wallets specifically for developers and security researchers. Which one of these wallets give the most assurance to professionals in the EVM ecosystem specifically? So if you're a Bitcoiner, this video is not for you. If you're a noob, you should also watch this video because we're also going to judge a wallet on whether or not I would recommend the wallet to the Bybit CEO. More information on that later. Now, a bit of a spoiler alert, I don't think there is a standout hardware wallet. With most things in technology, there's always trade-offs between different design choices here, and you'll find that that rings especially true when it comes to the hardware wallets. So before we go into any criteria, we need to know what the hell the purpose of a hardware wallet is. Well, the purpose of a hardware wallet is to keep your private key safe. That's it. If it cannot do that, it is not a good hardware wallet. Now, if you want to skip right to the wallet review, there is a link in the description to do so. However, there is some important criteria for us to go over first. So now, other than keeping your private keys safe, the main things that we're going to be looking at are how easy is it for us to know for sure what we're signing? As a security researcher, that is the most important thing that I want to do. There has been an epidemic of people blindly signing transactions and not actually knowing what they're doing. We're signing messages, and that's been causing us to lose billions of dollars in this industry, which isn't great. So which one of these wallets both show us EIP 712 data when we do a signature, and which one of these wallets show us the transaction call data? Those are going to be two of the most important pieces of criteria that we're going to be looking at here. If you want to fully understand what a hardware wallet needs to show us and why it needs to show us these different pieces of data, I have a video on my YouTube channel which goes over this in depth called What Are You Signing on Your Hardware Wallet, where we also show some examples of wallets that do a good job showing information and then do a bad job of showing information. The summary of that video is that when we're signing an EIP 712 message, your hardware wallet must show one of the full data struct of a message, the domain and message hash, or the final hash, and in our case, the SafeTX hash, and then ideally has an option to show all three, and the data is easy to extract directly off the hardware device. For signing/sending a transaction, it must show all the call data, the to address the contract you're interacting with, the nonce, network, gas, from address, etc., basic wallet information, and then ideally the call data is decoded, and that call data is very easy to extract off the hardware device itself. If the wallet fails to supply the information that it must supply, I must recommend that you do not use those wallets for any serious transactions. And unfortunately, some of the wallets we're going to be reviewing fall into this category. But in addition to those two, we should be looking at, is the wallet open sourced? If the wallet is closed sourced, I don't really know what you're doing, and maybe you're doing some fiddle nonsense with my private key that I don't want you to be doing. Now, full disclaimer, I'm not a hardware wallet specialist. I am a smart contract specialist. You show me a lump of call data, I can tell you pretty much right away what that call data is doing. You show me the insides of the hardware wallet, yeah, I'm gonna be a little bit lost. So there are some pieces of this that I'm going to be relying on other parties. For the open sourceness, I'm going to be looking at the wallet scrutiny review of these different wallets. The wallet scrutiny team actually takes the time to make sure that when a project says their code is open sourced, it's actually open sourced. And by open source, it means it's reproducible. Is the code that a team puts on the GitHub, does it match what comes with your hardware wallet? Now, next is we want to only trust what's on the wallet. Like I said, we're going to be using MetaMask as an intermediary for a lot of these hardware wallets. However, we want to assume that our browser is bugged, and we want to use our hardware wallets as the source of truth. So additionally, a lot of these hardware wallets have different security pieces, such as a secure screen, secure element, offline key generation, maybe some type of backup. All these other different features I'm sure are very helpful when it comes to you actually choosing a wallet, but we want to focus on our main pieces of criteria. Hardware wallet does what? Protects your private keys, shows you what you're signing. That's what we want to be checking for. Because if you can't verify you're signing what you want to sign, then I don't care how many layers of defense your hardware wallet has. If I end up signing some random bullshit because I can't read what I'm signing, then it doesn't matter how secure it is because I've just got rug pulled anyways. And the way we're going to be reviewing these is we're going to be doing a few main things. We're going to be connecting to the Safe Wallet UI. We're going to be attempting to sign a transaction. We're going to be attempting to execute a transaction. And in particular, for all these to level the playing field, we're going to be connecting through the MetaMask app. There was a time where the Safe Wallet had native integrations with different wallets such as Ledger and Trezor, but I don't think it's great to judge user experience based on how good the business development teams are. Now, why are we using MetaMask as opposed to Rabby or Phantom or Coinbase Wallet? Well, MetaMask is actually open source, so Coinbase Wallet and Phantom failed that test, so I didn't want to use them. Then it was Rabby or MetaMask, and MetaMask does a little better job actually decoding call data, so I went with MetaMask for those reasons. And after each wallet, I'm going to be giving them a Patrick rating and the pros of the wallet as well as the cons so that you can make an informed decision on what you want want to use. And then finally, for each one of these, I'm going to have a column that says, would me personally recommend it to our friend Bybit Ben, who, as many of you know, was hacked for $1.4 billion because him and his team did not verify the transaction data on their hardware wallet. And then also a column for would Patrick recommend this to security researchers. So with that all being said, let's start with the Tangem card wallet. The Tangem wallet is pretty unique in the fact that it's just a card. Everything about it is contained in the card itself. And a lot of people are like, oh, like it's just a card. Like you can never get your key out, blah, blah, blah. Just get a backup key when you get it. Like it's fine. And a lot of people have critiqued this card saying, hey, like if the mechanics in it break, then you're screwed. Well, that's also true for like any hardware wallet, and you just get a backup key like when you generate the key. So like chill out. As far as security of the actual card goes, it looks like it has a secure element for private key generation. And it's actually kind of convenient to use. Anytime you want to send a transaction, you really just tap the card to your phone, to your app, and then you're good to go. However, as a security researcher, that's where the good kind of stops. So first off, in order to use this wallet, you have to download the Tangem app for your phone. For some use cases, that's actually great. And actually for storing small amounts of money, I actually think this wallet is pretty solid, right? Like literally like a wallet in your phone, maybe load up $100 on it and go to, pay for your coffee with this wallet or something. I think it's a great option for that. However, it's closed sourced, first of all, which is bad. I have no idea what's going on in here. No idea what's going on in this chip. It could be doing anything. It could be storing my private key in a place that allows some hacker to take it easily. It could be adding a backdoor. I have no idea. Additionally, using the app is kind of an issue for me. I don't love the fact that I have to use the app in order to send any transactions. If my app gets hacked, really the app now is kind of the view into the key itself. So if my app gets hacked, I'm screwed. Because of that, if you want to actually use this as a key, I would highly recommend getting a brand new phone that you only use to send transactions. Now, this is one of the few wallets that I didn't connect to MetaMask because, well, quite frankly, there wasn't really an option to do so. But that's fine. The app that the Tangem wallet actually comes with has a Wallet Connect connection, which is great to use. So let's go over the two things that we need to do. We need to sign a message, and then we need to sign a transaction or send a transaction. The Tangem card wallet actually doesn't support testnets. And as a developer, that's really frustrating, but that's fine. I went ahead to Ethereum mainnet to test this one out. So what's good about this wallet is actually, if we go to the Safe UI and we go to sign a transaction on the app, we actually get populated a struct of all the data that we're actually signing. So this is actually really good. What I don't like is that this data is actually very difficult for us to review. And you'll see I actually have this critique for a lot of wallets. What would be much easier if it showed the safe transaction hash or the domain hash and the message hash? What am I supposed to do? Am I like going to screenshot this and then send it to my verifying device and verify it there? I guess, but that's kind of a pain in the butt. The good thing is that it does show us this struct at the very least. Now, the more frustrating part is the call data. When I go to actually execute a transaction, this is what it shows me. There's nothing. There's no reference to what the call data is. There's no reference to what the signature I'm using. There's absolutely nothing. It says, hey, do you want to sign and send this? Yes or no. So when you're sending transactions on this device, you're doing it completely in the dark. There's no call data of any kind. And for that reason alone, would I recommend this to our friend Bybit Ben? Absolutely not. So for security researchers and developers, it is unacceptable for you to use this wallet. However, if you want something quick and you don't really care if you lose $50 or $100 or however much money you load up on this card, great, you can use it. But for working with DeFi and working with the EVM, I say this is an absolute no, you should not use this card because you cannot see the call data. You have no idea what the transaction is that you're sending. So final ranking here is going to be a 1 out of 10 stars. Moving on to the next, the Cypherock. So the Cypherock, just by the fact that it's open source, gets a level up. We'll get more points because of that. The wallet scrutiny team has gone through the Cypherock. It is reproducible. It is open source, which is absolutely fantastic to see. The fact that the app that it comes with for your computer is like 8 gigabytes is kind of ridiculous. They also come with all these cards, which you tap to the device to actually send transactions. And that is kind of nice and convenient. This is another one though, that I could not connect to MetaMask or Ravi or any software wallet, which I was sad to see. However, the app itself actually did come with a Wallet Connect integration, kind of same as the Tangem wallet, which was really nice and made it easy to work with the Safe UI interface. This does have a secure element, which was EAL6+ rated. You can connect it to your computers with a USB connection, and I was pretty excited to work with this wallet, and then I started to use it. So let's talk about signing first. We connected to the Safe UI, and we went to sign some EIP12 data. When you go to sign, the app first goes ahead and shows you the data, and then it shows you on the hardware wallet as well. Now, this wallet having this little joystick here being the way you interact with it, was really frustrating. When I wanted to name a wallet, you have to go left to right through the entire alphabet and then like click the center button to do stuff, which really sucked. A lot of these smaller wallets have this issue where they're meant to be really simple and therefore safer, but the user experience really leads to some security fatigue. But here's where the Cypherock completely fails my test. It showed me some of the data for signing. Then I went to go and execute, and it showed me absolutely zero call data. So what, I'm just gonna blindly send this into the void and what, just pray the Ethereum nodes like know what I want my transaction to do? So unfortunately, for that reason alone, do I recommend this to Mr. Bybit Ben? And the answer is absolutely not. You cannot and should not be ripping your transactions into the void, not being able to see the call data. You have to be able to see the call data. So for that reason, Cypherock gets a no. Would I recommend the Cypherock wallet to a security researcher? Absolutely not. But I will say the wallet itself was really easy to use. The app was super intuitive. And so for a wallet that you store like a little bit of money in, to do like day-to-day stuff, I think this wallet is probably fine. But the fact that because for at least signing data, it shows you the data, I'm going to give this a 3 out of 10 stars. Obviously, I docked a ton of stars for not showing call data, which is one of the most important things you need to show. All right, moving on up to the Keystone Pro. And now we start to finally get into wallets where most of the interactions actually happen on the wallet itself, as opposed to the app, which we absolutely love. And this was a touchscreen, which was really, really nice to work with. And it made setting passwords, doing backups, kind of doing anything on the hardware wallet a lot easier. Wallet Scrutiny went through this and did verify this was reproducible, which was great to see. Now, some of my hardware wallet expertise kind of falls off here because there was a whole bunch of marketing saying like, oh yeah, we're PCI compliant, which is like the compliance for like credit cards and stuff. I don't know if that's better than their secure element being like EAL6+. I've heard some other wallets are trying to be PCI compliant as well. Whatever, I'm just gonna go on to the things that I think are more important anyways, which is once again, viewing the data. Now, many of these wallets had a custom way to connect to MetaMask, and the Keystone wallet used a pretty novel QR code solution that I actually thought was pretty nice. I'm gonna go ahead, I'm gonna select the little 3 dots, connect software wallet, select MetaMask. It's going to give me this QR code that I'm going to select. And then in my MetaMask, I'm going to go to my accounts, add hardware account, QR based, scroll down, hit continue, allow to use my camera. And I'm literally going to show this QR code to the screen. It'll be blurry and that's fine. And it'll pop up a list of wallets associated with this wallet. So I'll select the wallet, I'll hit unlock. And now it says Keystone 1, and it is now in our MetaMask. So does it pass the test for viewing the data? Well, for signing EIP712, it sure does, which was great to see. I was able to connect to the Safe UI through MetaMask, a signature populated on my Keystone wallet, and I was able to see all of the data that I was signing. Once again, it was in the struct format instead of the safe TX hash format, which was too bad, but at least I could see all the data that I was going to be signing. So what about the call data? Well, here is where I really wanted to like the Keystone Pro, but it just barely let me down. So one of the things the Keystone Pro boasts about in its marketing information is that it decodes all your call data. And remember, at the beginning of the video, I talked about how decoding your call data is basically making it more readable. And that's what we want. We want our wallets to be readable. However, when I went to execute a transaction, it decoded some of the call data and it left some of the other call data just completely blank. And I tried this multiple times and sometimes I got it to work. The Keystone wallet has this process where you can download a whole bunch of decoded call data essentially into this micro SD card and put it into the Keystone so that it can actually decode all this call data. And I went through that process a few times because I was like, okay, maybe I was downloading it wrong and have the right call data, but I kept getting missing call data or truncated information, which kind of almost defeated the purpose of decoding the call data. I found that even in the documentation, they had an example where the data wasn't being decoded properly or that the data was just missing. If you're going to decode the call data, you better do it right because it's much worse if you do it wrong. And this is actually why I always want there to be an option on my hardware wallet to not decode the call data because sometimes I don't trust you. And for the Keystone wallet, this is a scenario where, okay, there was enough times where it decoded the call data incorrectly that I couldn't trust it. So I really, really wanted to like the Keystone Pro. It's open source. It's got a touch screen. It has this micro SD card, which allows you to decode the call data. It like was sprinting to the finish line and then it just kind of like paused right before the finish line. And it just, if you're gonna decode the call data, you gotta decode the call data. You can't like half do it. It's actually much worse the way that it's being shown here. Now this would have been fine if there was a way for me to turn off decoding the call data, but I couldn't find such a setting, which was too bad to see. But other than that, working with it was really easy. It felt like a really solid default wallet. For that reason, would I recommend this to Bybit Ben? The answer is absolutely not. Keystone Pro to a security researcher, it's too buggy. So I must say no. For ranking, I would give this 4 stars out of 10. Open source, great. touchscreen great, usability great. Had a really hard time with decoding the call data, which almost defeats the purpose of decoding the call data at all. All right, moving on to the Trezor Model T. This is one of Trezor's older models, and this is what I would argue to be like a very solid default wallet. So I'll give you a little bit of spoiler. I'm going to rate this a 5 out of 10, which is like, oh my God, 5, that's so bad it's failing. For me, a 5 out of 10, if you follow like a normal distribution curve, that's actually, for me, it's right in the middle. That means it's like a solid wallet. For me, this is one of the first like default, okay, this wallet's okay, but you'll see in a second some of the drawbacks. I was able to very easily connect this to my MetaMask, and this is open source, as verified by Wallet Scrutiny, which is absolutely fantastic to see. I know that the team is not trying to screw me over, which is wonderful. It had testnet support. I was able to set a key path, which is important for working with testnets. And the biggest issue that I ran into was, okay, well, why did they make the Trezor Safe 5? So you'll see in a second, we're going to be going over the successor to the Model T. Why did they do this? Well, one of the main changes they made from the Trezor Model T to the Safe 5 is that they added this secure element to the Safe 5, which is not in the Trezor Model T. So I was kind of snooping around the forums and I found a Trezor mod who basically explained it, saying, hey, the Safe 5 is better because it has a secure element. The Model T, if someone is clever enough, they can break into it and they can steal your private key, which is terrifying. Similar to the Keystone, this is also a touchscreen. However, I found it much less usable because my Shrek thumbs were having a hard time pressing buttons. I kept accidentally pressing the wrong button because of how small the screen was. However, going through the settings and working with it was rather intuitive. And this is again why I feel like it's a very good default wallet. But once again, not having that secure element is probably enough of an issue to say, hey, this isn't a wallet we could recommend to buy BitBen. Trezor Model T, you don't pass the threshold. But let's go ahead. Let's talk about signing and call data. So when it comes to the EIP 712 data on the signature, when I did it through MetaMask, it actually showed me just the giant struct and not the Safe TX hash. This was kind of frustrating because almost a month ago, I connected it directly to the Safe UI and it did show me the Safe TX hash. So I'm wondering if there's some weird connection between MetaMask or some intermediary where it skipped that step. And because I wanted to keep the playing field leveled, everyone was going to be connected through MetaMask. And when it was connected through MetaMask, it did not show the Safe TX hash, but it did when it wasn't connected through MetaMask. And so that's like, why is it different in different scenarios? I don't like that. But it did show the struct, it did show the domain, the types, the values, etc. But what was quite frustrating is it did it one at a time. So I kept having to like click next, next, and next, and next. And that can lead to what I like to call security fatigue. Whereas the Keystone Pro, what was really nice about that is it showed that whole thing kind of like one go, or chunked it. Basically, it showed you different chunks, which was much faster for me to verify. So it actually showed the signature data, and the Model T here did show us all the call data, which was awesome. It is the first wallet on our list that we've gone through that has shown us all of the call data for a transaction. The issue is that this is how it shows you it. What am I going to do with this? Like, this is awful to actually verify. So getting this information off of my Model T into some device where I can actually verify the call data is very, very difficult. It doesn't decode the call data. It doesn't show a hash of the call data. It's very difficult for me to verify the call data is actually correct, but at least it shows it. So I do have the ability to verify it, which is what's most important. So the question is, do I recommend this to buy BitBen? The answer is still no. And the answer is no, because the Trezor Safe 5 is better because it does have this secure element. However, the Trezor Model T, I do give a rating of 5 out of 10. But once again, along with kind of all the other wallets here, this isn't a wallet that I would put a lot of money into. It is a great wallet for people looking to kind of learn how hardware wallets work. But once again, there's almost no reason to use it now that the Trezor Safe 5 exists. So yeah. So moving on, let's move on to the Trezor Safe 5. So Trezor Safe 5, along with the Trezor Model T, is another wallet that passes the wallet scrutiny test of open sourceness, which we love. We love seeing that. A lot of the firmware that we see with the Model T is really, really similar to the Safe 5. So if you're familiar with the Model T, you're probably going to be familiar with the Trezor Safe 5 as well. The touchscreen is much bigger, so my big fat fingers have a much easier time pressing the buttons. There's some haptic feedback, which I didn't think would be a big deal, but it's like a huge deal. It makes it feel so much better when I press buttons on this touchscreen. You have to adjust some of the settings to work with a testnet, but it does eventually work with the testnet. This one, unlike the Model T, it does have a secure element, which is EAL 6+ rated, which once again, I don't really know what that means, but I'm assuming it's a good thing. Higher number is more better, I guess. It has offline key generation. The Keystone restore process is fine. However, some of the options were completely unintuitive. And that made me almost want to say, like, screw this wallet's terrible. When I wanted to view call data, I had to swipe the wrong way. I couldn't go back. Just listen to me the first time I tried to view all the call data.
Okay, swipe, cancel and exit is swipe up. What if I swipe right? Continue anyways. There we go. There we go. So now I have the input data. This is the call data, which is great. This is what I want. Why don't I have all the freaking call data? Oh my God.
The mistake I made is here it says confirm swipe up, and there's no indicator that says swipe left to get the option to view the rest of the call data, which was super bizarre. And it felt like getting to the next screen that I wanted to go to was completely unclear, which was frustrating because the Model T was super straightforward and super clear. Like, the Model T's intuitiveness was better than the Trezor Safe 5's intuitiveness. Like, I could see eventually, after using it for a while, getting used to working with some of the options, but it was completely unintuitive, and I really hope that they make some updates to the firmware to make it more intuitive. Now, let's talk about signing in call data. It shows you all the domains, types, and message, doesn't show you the actual hash, which, once again, seems to kind of be the default for most of these wallets. I'm sure the same scenario would hold true for the Model T. Maybe if I connected natively to the Safe UI, it would have shown me the Safe TX hash, but we were doing it through MetaMask, so I digress. Did it show me the call data? It sure did, but again, was super weird to view the call data, and scrolling through it was weird and very unintuitive to view the call data, but at least I could see the call data. It doesn't decode the call data, which is too bad. So now the most important question, would I recommend this to Bybit Ben? And this is where we finally get a maybe. The reason I'm not giving it a hard yes is because verifying the call data and the signature information is so hard for an average user. Now, I don't know how technical Mr. Bybit Ben is, but I'm assuming he is not going to be able to verify call data or verify, this giant struct on a multi-sig transaction is correct. So because it's so difficult for him to actually verify that information, I'm gonna say maybe and probably lean towards no. Now, for someone who's more technical and a security researcher, I'm gonna say absolutely yes, actually. It's open source, it has a secure element, all the information is there, and open source can actually be a make or break for a lot of people. We know that the Trezor isn't like sending our information to North Korea because it's open source. You just need to be absolutely sure you know how to verify call data and you know how to verify those signatures from kind of their more raw format. Because again, it's not showing you the safe transaction hash and it's showing you the call data in this kind of horrible format. Honestly, a few improvements to this, and this could be an absolutely phenomenal wallet. Number one, make the UI more intuitive and don't make these options super weird. Number two, show the safe transaction hash even when you're connected to MetaMask for signatures. And then number three, have an easier way to view the call data, maybe show a hash of the call data, maybe try to decode the call data, or show a QR code of the call data that you can scan and you can view on whatever verification device you like. 7 out of 10 for the Trezor Safe 5. The Ledger Nano X. I feel like back in the day, the Ledger Nano X was like the wallet that everyone had. I've had this ETH Global branded wallet that I've had forever because you should never ever use a wallet that you get from a hackathon as your guaranteed wallet. But for this video, I said, screw it. Let's go ahead and test this on a different device. And it turned out to be fine, but I didn't put any real money on it. So who knows? Now, Ledger as a company has had some challenges. What's good is none of those challenges have actually been breaches of the wallets themselves. So yeah, their marketing team made some very questionable choices. They had some very unfortunate data breaches, but as far as the hardware wallets themselves go, they've had a really good track record, which to me is arguably more important than the fact that they told you to wear your hardware wallet around your neck, but I digress. So the Ledger Nano is not open source, it's closed sourced. So we just went through this beautiful list of 4 open source wallets, and now we're back to closed source, unfortunately. We don't love that about Ledger, but it is what it is. The Ledger Nano X closes very often, which is probably good, but when I connect it to my MetaMask and then I go, populate my transaction and I go back and it's closed immediately, that's really frustrating. It's really difficult to hit back when reviewing data. The way that it works is it has basically these 2 buttons on it, and you can go right, you can go left, or you can hit enter by tapping both of them at the same time. Really, really small screen, which makes kind of showing a lot of information difficult. There's only so much you can show on this very teeny tiny little screen here. There are some nice features like the Ledger Live app that comes with it is actually very solid. There's a firmware checker. Actually, most of these wallets have some type of firmware checker, which is great. It has an EAL5 Plus secure element for its chip. So does it show the EIP 712 data on sign? It does. And this is actually the first wallet out of the whole list that we've seen that even when connected to MetaMask, it shows the domain hash and the message hash. And this, I cannot stress to you how stellar and how much easier this makes verifying signatures is. This is a big, big step. right? Because imagine all you have to do is look at these two hashes and say, cool, this looks good. Or you have to look at this giant like struct and jarble of data, which is much harder to do. This is the first wallet that gets 2 thumbs up from me of like, yes, you show the domain hash and the message hash at least. So big round of applause for Ledger for actually having that. That's like absolutely massive here. We run into a little bit of an issue though. So first off, in order to see both the struct and the domain and message hash, you had to enable this setting. For some reason, it would send 2 requests to my Ledger to sign this, and I could accept either one. So it sent me one with the whole struct, which was great. I'm glad they sent me, the domains, the types, and the message. But then if I rejected that one, it sent me another one with the message hash and the domain hash. Like, why don't you just send me both in one request? That was like kind of odd. And if I rejected one and accepted the other, it sent it through. So it felt like very weird that it did that. Probably just a little bug, and it'll probably fix it in a future update. Now the call data, it doesn't do so hot. In order to send a transaction, you have to turn blind signing on. Essentially, blind signing means signing a transaction where the call data is not decoded, where it's just raw call data. And this is 100% a term that Ledger just kind of came up with themselves. And in order to send pretty much any Ethereum transaction that's not like just sending ETH, you have to enable this feature. And anytime you send a transaction, it'll say, hey, like you're blind signing. Are you sure you want to do this? Blind signing means call data is not decoded. Clear signing means call data is decoded. How deep do you decode the call data in order to call it clear signing? It's a little unclear to me, but okay, sure. We turn on blind signing, no problem. Now, the next thing you have to turn on though, for some reason, the setting they have to show call data is called debug contracts. And it says displays contract data details, which is very cryptic. And it's almost like they aren't sure what the call data is. Once you enable this, if I send the transaction, the exact transaction takes 10 parameters. But on my Ledger device, it will show me 18 parameters. So for a while, I was like, what the hell is it talking about? It says, hey, field 1 is this, field 2 is this, field 3 is this. There's 10 parameters, but it's showing me 18. So what I found out eventually was that first it shows the function selector, which is great. We love that it's showing us that. And then it just takes the rest of the call data, chunks it up into 32 bytes, and just shows you a 32 byte, a 32 byte, a 32 byte, and just says each one is a parameter. Now, for those of you who are more technical, you know that dynamic types like arrays, for example, that's not how they work. You have a 32 byte, which tells you when the dynamic type starts. You have a 32 byte that tells you how long the array is, and then you have the different elements in the array. Would be correct if there were no dynamic types, but there are dynamic types. So it's like not really correct. And then additionally, it shows you it in this super bizarre format. Like this isn't hex, it's truncating with these colons and showing these zeros. So like after using it for a while, I eventually figured out, oh, okay, like it's this many zeros when you see this colon here. Now that I know it's in this weird format, okay. But the first couple times I used it, it said, hey, this is field 1 of your function. I said, okay, that's not what's field 1. My field 1 is a dynamic type. Why are you showing me this weird, bizarre thing? Technically, it's all there, but I would way rather the setting just say show call data and then show it in like normal hexadecimal format instead of this weird Ledger format. Does it decode the call data? No, and it shows it in probably the worst format out of every wallet here. How easy is this to use? It's a huge pain in the ass. I'm not going to sugarcoat it. The 2 buttons are gross. It's hard to do stuff. Don't love working with it. But again, this is one where I think if they make a couple of tweaks to the firmware, make a couple of updates to the setting, this could actually be a phenomenal wallet. Do I recommend this to Bybit Ben? My answer is no, but only because the Ledger Flex exists. The Ledger Flex, which we're going to go over in a second, is also substantially better than the Nano X. So I just feel like you should just get the Ledger Flex if you're dead set on a Ledger. And the fact that it's closed sourced, I would rather you choose the Trezor Safe 5 over the Ledger Nano X. Would I recommend this to a security researcher? Probably not. It's like, it's closed sourced. If they used it, I would say it's fine, but it's closed sourced and you might as well just use the Ledger Flex if you're going to use a closed sourced option, because the Ledger Flex is much more usable. Speaking of which, let's go over the Ledger Flex. Now, you can actually tell that the Ledger Flex shares a lot of the software with the Ledger Nano X, because most of the critiques I have with the Ledger Nano X, I also have with the Ledger Flex. But the Ledger Flex has a ton of advantages that I love to see. Some of them being the Ledger Flex actually has a secure screen so that you know what's showing up on your screen is actually what is showing up. The usability on the Ledger Flex is night and day. It's got a big screen. It feels really good to press the buttons. I absolutely really like touching all the buttons on the Ledger Flex. It feels really good. It closes much less often than the Ledger Nano X. Like, it stays open for an amount of time that I would want it to do. Once again, love the firmware checker, and it feels like a very solid upgrade on the Ledger Nano X, just kind of better than the Ledger Nano X in every way. Very easy to use. Once again, unfortunately, it's closed source, but I digress. Does it show EIP 712 data on signing? Yes, it does. And it's actually similar to the Ledger Nano X, where it will show the domain and the message hash, which is phenomenal. You can enable that option to actually see the raw struct as well, which is great. I don't know why it sends it in 2 different requests. I kind of hate that. But the fact that I can see those very easily, like on the screen, was amazing. Absolutely amazing. I don't love how the Ledger Flex is closed sourced. However, for this feature alone, showing the domain and message hash when connected to MetaMask, for your EIP 712 signatures, fantastic. That reason alone is why somebody might use this wallet. Now, viewing the call data has the same issue as the Ledger Nano X. Hate this format. However, I hope they see this video and it's like a really easy fix. Would love them to decode the call data as well, but that might be too much to ask. But at least don't show it in this stupid format. It has the exact same setting names like debug, contract details, a weird name for the setting. To show call data, yes or no. And then it's like, no, it's not 18 fields, it's 10. You just kind of blindly said, oh yeah, like every 32 bytes is a parameter, right? Secure element, EAL6+, great. Would I recommend this to ByBitBen? Yes, with a big asterisk here. So this is the first one that I'm gonna say maybe, but lean on the side of yes, actually. For signing data, absolutely. Because ByBitBen could use the wonderful Safe utils by OpenZeppelin to get the domain hash and the message hash and compare it to what they see on the Ledger Flex here super easily, and I love that. For that reason alone, the answer is yes. However, I would recommend that ByBitBen not be the one to execute the transaction, because viewing the call data is borderline impossible. Would I recommend this to a security researcher? Yes. Asterisk again. Don't love that it's closed source. If you're okay with that, then yes, I would recommend this to security researchers, because you can verify the call data, you can verify the signatures, all the information you need is there. User interface is really, really intuitive. Patrick ranking 7 out of 10. Moving on to the Onekey Pro. Now this wallet was so close to being the champion wallet, because they said they are open source. I was so excited when I heard the Onekey wallet was actually open source, but Wallet Scrutiny team actually found out that the build was not reproducible, meaning that the code that turns up when you buy your Onekey wallet doesn't actually match what they put on GitHub. So maybe this is an oversight, or maybe the Onekey team is trying to sneak something by us, which is kind of terrifying. So I'm really looking forward to when they actually pass the Wallet Scrutiny test and they can be provably open source rather than what they currently are now, which is not quite. There were a lot of things I really liked about this wallet. Haptic feedback when you actually go to punch in your key codes. The wallet feels really good. It has a lot of great features like air gap mode. It actually uses the Trezor tech to do a lot of integrations, which again, because Trezor is open source, they are able to do that, which again, kudos to Trezor for being open source. Offline key generation, EAL6+ secure element, testnet support, very easy to use. Seemed like a very, very solid wallet. And I've thoroughly enjoyed working with this Onekey wallet. So now let's talk about the important ones, signing and call data. So when you actually sign with this wallet, does it show the EIP 712 data? It absolutely does. It does not show the domain hash or the message hash, unfortunately, at least, while we were connected to MetaMask anyways, but it does at least show chunks of the domain types and message data. So once again, this one will take a little extra work to actually verify, but at least it has all the data and it shows it to us. So that's what it looks like when it comes to signing. For actually sending transactions, we have a similar story to the Ledger Flex or Trezor. It does indeed show us all the call data, once again, not decoded. And now importantly, do we recommend this to ByBitBen? And I went back and forth on this, but I think the answer here is no for the same reasons the Trezor Safe 5, the answer is no. It is easy enough to go through the actual struct, the actual data when you're signing the EIP 712 data to understand what's going on, even though it doesn't show the domain hash, message hash, safe TX hash. But when it comes to the data section of the message, I would still rather someone who's technically trained. So if Ben from Bybit is trained on decoding call data, then I would say that yes, this is okay, so long as, once again, their team is okay with closed sourced software. Would I recommend this to security researchers? If it not being open source is something that doesn't bother you, then yes, I would recommend this to security researchers. Very easy to see the signature data, very easy to see the call data. I would love it to be much easier. Once again, maybe flash a QR code to pull the call data off and pull the signature data off so that you don't have to go through one by one. This is like one step away from being a fantastic wallet. This one is also going to give a 7 out of 10 from me, and it probably would be an 8 or even a 9 if it was actually open sourced. And last but not least, the Grid Lattice Plus. Now, when I was originally choosing a wallet several years ago, this is one that I immediately crossed off my list because it was closed sourced. And we actually did an interview with Justin, one of the co-founders of Grid Lattice Plus, over on the Cypherock channel, and talked to him a little bit more about that choice. Basically, it came down to the fact that the chip that he wants to use for the Grid Lattice Plus is proprietary. So they're using a proprietary chip that they're not allowed to open source. And for that reason, it must be closed source. Now, they try very hard to make everything else open source with the Grid Lattice Plus. However, the chip is closed sourced. For that reason alone, I did indeed dock this points. This is easily one of the clunkiest wallets, all of them. It's this giant monstrosity. However, because it's a giant monstrosity, it has a ton of screen real estate, and I actually love that. It has this feature where if it gets dropped or physically damaged in some case, it automatically wipes. Because I am a giant clumsy man, I turned that feature off right away. I'm damn sure I'm going to drop this at some point, and I would like to not have it be wiped. The chip is EAL 6+ rated, and honestly, working with this device is one of the smoothest out of all the devices. Pressing buttons is really easy, even for me with my Shrek paws. What I don't love is that connecting to MetaMask was very tough. You did have to connect over Wi-Fi. I loved that as an option, but it's very spooky to me to be connected to Wi-Fi and be sending transactions and stuff. I've been told it is just as safe, if not safer, as USB or Bluetooth. However, I would love a way to send my transactions not through Wi-Fi. So let's talk about signing and call data. Same as most of the other wallets, when connected through MetaMask, it shows the EIP712 data in chunks. You can verify piece of data by piece of data. Once again, a slight improvement here would be to show the message hash and domain, or at least the safe TX hash. At least it shows the data in a very clear, very readable way. And when it comes to the call data, this is the feature that makes this wallet borderline the best. If any of the open source wallets had this feature, in my mind, they would win, full stop. But unfortunately, they do not. So this feature on the Grid Lattice Plus is absolutely amazing. But when it comes to decoding call data, I usually get very upset because people often say it's a one-stop solution to signing transactions. It's actually just a piece of the puzzle, because often inside your transactions, there's more encoded transactions that you have to decode, and you have to do layers and layers of decoding. Not only decodes your transaction, but it'll decode nested transactions if it's aware of them as well. And this is a feature that is absolutely phenomenal, especially if you are non-technical. This is my genuine reaction the first time that I ever sent a transaction where it decoded my call data and then decoded my nested call data.
Wow, so this even decodes the call data, which is actually really nice to see. Wow, it even does a nested decoding. That is f***ing insane. That is really cool. Wow.
But here's what I didn't like about it. I have to trust that it is decoding things correctly. If it decodes something wrong, that's terrifying to me. I don't want to have to deal with a wrongly decoded transaction. So I was searching for an option to turn off transaction decoding, and I didn't find it. And I didn't like that. I want to get the raw call data so I can be absolutely sure of what I'm signing. So it was fantastic that it both decodes the call data and decodes the nested call data. I cannot stress how phenomenal of a feature that is, but I would have loved to have been able to just get the raw call data as well, so that if I want to verify the call data myself, I can. Now, because of how readable the data is, would I recommend this to Bybit Ben? And my answer is yes, for both signing and sending transactions and executing transactions, so long as Ben has been trained to understand what the decoding call data looks like, and telling Ben that if he doesn't understand something, he should stop immediately. Now, would I recommend this for security researchers? Once again, if you're okay with the fact that this is closed source, then I would say the answer is yes. So the Grid Lattice Plus, for me, just a small couple of improvements. I would love an option to actually get all the call data as opposed to it automatically decoding it. However, I love that the default is that it does decode it. And then obviously I would love the domain hash and the message hash maybe the safe transaction hash as well. So this is actually the only wallet that I'm going to give an 8 out of 10 rating to. However, just because it's rated the highest doesn't mean it's the right choice for you. For a lot of people, choosing one of the open source options is still going to be a better choice. In my opinion, if you choose one of the open sourced options instead, I think that is a very respectable decision. And it's going to be up to you whether or not you want to trust the team that is working with the wallet or not. For me, open source is really important for me. And I can read call data. I can read signature data. I know how to decode call data. So maybe I forego some of the readability for the open sourceness because that's something that's important to me. But maybe that's not something that's important to you. Maybe the readability is more important. And in fact, I would highly argue if you cannot read your transactions, you shouldn't be sending transactions. Please don't send any transactions if you don't know what they're doing. Please, I beg of you. So there you go. That's the ultimate review of these 9 wallets, specifically for security researchers and a little bit for Bybit Ben as well. And of course, this is just my opinion. For security-minded folks, if you're like me and you like open source, the Trezor Safe 5 might be the best solution for you. If you're okay with closed sourced, then the Grid Lattice Plus is a fantastic choice. Ledger Flex is even easier to read signed data. There's no wrong choice here. There's just trade-offs. So with that, hope you learned something. If I got something wrong, leave it in the comments, and I hope this video helps you select a hardware wallet for yourself. All right. Thanks all. Take care.